All right, all right. So welcome back. Most of you, or all of you, should have received an email from me, okay, with your grade and how you did on the midterm, all of that stuff. So, a lot of you came to office hours, which is good. And again, so if you haven't come to office hours, or you have questions about your grade, you can ask me. You can see your midterm exam and see exactly what happened on the test, so on and so forth. Okay. Performance on the midterm overall was okay. We have some students with over 100% in the class. We've got probably about 5 or 6 students like that, doing very well. And then we have a handful of students, more than I would like, who are getting D's or F's. Okay, either failing or just not doing well. Okay. If that's you, so if you're below 70% right now, okay, this applies to you, or actually this applies to many of you. If you're not doing as well as you would like to be, okay, then you need to change something that you're doing. Okay, so maybe you are doing all of your homework, okay, and if that's the case, then apparently it's still not enough for you. Okay, so maybe you need to work with someone else, maybe work with another student who's doing well, or work with a tutor or something. So there's papers on all of your chairs and stuff. I have no idea who this person is. Okay, I have no idea who he. I think it's a he. He comes in every quarter and he puts papers all over my classroom, and I actually don't appreciate him doing that, but because a lot of them just end up getting thrown away, and I end up having to clean up after him sometimes. So I wish he wouldn't do that. I have no idea if he's any good or bad. I have no idea. I have no idea what he charges. I am not endorsing nor denouncing him or something. But you know, if you do seek tutor, okay, a tutor or help from someone else, okay, this is what I strongly encourage you: is do not do the homework with the tutor. Okay, do not pay the tutor money just so you do the homework together, because you will not learn that way. All right, because what ends up happening is your tutor does the homework and you watch, and you don't learn anything. Okay, all that happens is your homework assignment gets done, which you could have done on your own, and it will seem like everything makes sense because the tutor's doing it and explaining things along the way. But when it comes to test time, you will realize you actually didn't learn what was happening. So if you do hire a tutor, do the homework by yourself, and then you will probably get stuck, or you'll probably have questions, okay? And wherever you get stuck, write down a question. You know, what am I supposed to do? What is this? Write down a question, okay? I mean, I do the homework for you in the videos, but if you're going to hire a tutor, try to do all the homework you can without the video. Anytime you get stuck, write down a question that you then ask your tutor. Okay, that's a much better use of your money. You can come visit me during office hours. I have them every week from 5 to 6. I'll try to help you out, answer questions. Of course, depends on how many students show up, the amount of attention I can give you. So, you know, I don't know. Some of you probably aren't going to pass at the end of the course, and it makes me sad to say that, because I do want all of my students to succeed, but I also am aware of the reality. So, well, anyway, if you have any questions about your grades or anything, you can send me an email or you can Are there any overall questions right now? Okay. Then we'll move on. Yes, question.
So is the new chapter the one that students have most trouble with, or was that the chapter 5?
Okay, so probably the hardest chapter in the course, or this, I wouldn't say the hardest, but just the chapter that students have the most trouble with is probably chapter 5. Okay, but then, in my opinion, the chapters overall, the chapters after the midterm are harder than the chapters from before the midterm, with the exception of chapter 5. Okay, but overall, I think the later chapters are harder than the earlier chapters. I try to present it in a way that makes sense and you can work through, but there's a lot of information. Yes?
Are quizzes next week?
Yes, you have a quiz next week, okay? And it's going to just cover stuff, everything that we do today, okay? So there's only 1 day or 1 week's worth of stuff on next week's quiz, and it's basically the stuff from today. Okay. Well, the stuff from today does build up on previous stuff. Like, you need to understand the normal model in order to do today's stuff. Okay, and if you don't understand the normal model, you'll be in trouble. Okay, and that applies to more than I would like. Okay, because on the midterm, the free response, there was a question about gorillas, and I think it was gorillas, right? It was supposed to be a straightforward normal model problem. I was surprised by the number of students who did not make it through that problem. Okay. The problem on gorillas, you draw the, what percentage of gorillas are between 300 and 280 pounds or something like that, right? The average gorilla weighs 310 pounds or something, and something like that. Something like that, okay? I was surprised by how many didn't get that right. I don't know, I like to think that I'm doing my job teaching, okay? And I feel like I am, all right? I feel like I try to present the material in an understandable way, and then provide you with videos and resources to get you through it. But some of you still aren't doing as well as I would like, so seek help. Seek help for things. Okay. Is that okay? All right. We'll get through it. All right. And
do you want to go through that gorilla thing with us, just so we have a recap, if that everyone had it wrong?
Okay. All right. Sure. Normal model problem. Okay. So then here's this is an opportunity, and I do this during my lectures. I say, all right, we're gonna work through a problem, and you guys should work through it. And I would say maybe about 30% of you just sit there and don't try the problem. And I feel like that correlates highly with poor performance in the class. Not that one causes the other, but I think the two are connected. All right, but we'll try this. Okay, we'll do a normal model problem. All right, we'll say. I got to be mindful of time because we have a lot to cover today, but it's okay. This is all right. So we'll just say the weight of cows follow normal model. Okay. The mean is 510 kilograms, and the standard deviation is 40 kilograms. All right. cows weigh between, let's say, 450 and 515 kilos. So you will need your normal model table. So go ahead and try to answer this question. Take a couple minutes.
Oh, he's
So you should write some stuff.
Do you follow, right?
If it's 5 or higher, you round it. If it's 4 or below, you don't round it. So it's 0.1 divided by 0.1, but it's negative. Oh, divided by 0.1, it's negative. Yes. Yeah, it's negative. It's perfect. It's 5 times minus 5. Oh, yeah. It's negative, right? So large. But this is not the standard. Mean is here. Mean is here. But the mean is. Oh, I see. So it's not.
Oh, it's like, sorry.
This is not the mean. So
It was divide the figure by the square, right?
I don't know. So that's 0.125. So this is wrong.
Oh, yeah, you're
Is that right?
I don't know. I got something different.
It's not right. I got something right. It's 0.125, not negative 0.125. It's not negative, it's not. Isn't it positive 0.125?
Did I mess something up?
Oh no, you didn't. I'm looking at it wrong.
Are they wrong?
No, it's positive. That one's negative, but the other one's positive. Yeah, this one's positive. I got it. 5 right? 0.1 is 5.
Maybe it's just gonna be like 1 point.
That's right.
Brown.
I'm right. He's right.
Can you see what is the value of
Point 1, 3. Because you round up. Because it's only two decimal places, but we
See,
only
that's
have
the
one on
tricky
there.
part.
So you round it up. You round it to 0.13.
Yeah.
So 0.13.
That's
All right. Okay. So I was walking around again. Some of you guys, some of you guys are doing great. Okay. Some of you guys are doing great. You guys got it. You're working through problems. Make me happy and proud. Others of you, you're breaking my heart. You know. I just said this is the opportunity for you to actually try out the problem. And as I walked around, some of you just had blank sheets, okay? At least copy down the problem, all right? And at least try something. I don't know. I can't. I'm doing as much as I can, but you've got to work with it. You've got to work with it. Okay, but let's. All right, let's work through this. All right. So my answer is 48.49%. All right. So if I were to draw a picture, in the center I would put 510. All right, you guys. Just I know some of you are explaining the problem to your friends, but let's if I could just ask you guys to be quiet for a little bit, and we'll get through this. Okay, so one boundary is 515, the other boundary is 450, and we want to know how much is in between those two spots. All right, so we got to find the z-scores. Okay, z-score for 515. So that's z is equal to 515 minus 510 divided by the mean of 40, and I get 0.125. It's very important that we put the mean and the minus the mean. Okay, some of you guys had that mixed up. You're going to get the negative of the answer. Here we have 0.125. Okay, now we look this up in the table. Okay, the table only has 2 decimals of precision, so I'm going to look up z is equal to 0.13. And then the number I look up, the area, is 0.5517 when I look that up in the table. And then on the other side, 450, we do the same thing. 450 minus 510. Again, it's important that we do the minus 510 and not 510 minus 450. And here I get negative 1.5. Okay, I look this up in the z table. Look up z equals negative 1.50. And the area is 0.0668. So the area in between is going to be 0.5517 minus 0.0668, and I'm left with 0.4849. And this is my answer. Okay? Or turn it into to a percentage, 48.49%. Yes,
How'd
Fran?
you feel if we didn't round out the,
And you use 1.2?
yeah?
That's okay, all right? If it's a multiple choice test, this would be your answer choice. If you use 1.2, and technically it's not correct, right? Because
Right.
you should know how to round, okay? If I round this to 2 decimal places, you look at the spot that comes after the place where you're rounding, and if it's 5 or higher, you round up. So this would go to 1.3, okay? This goes up to 3. Otherwise, you round down and you just leave it at 1.12. And I know, I'm not trying to embarrass you, but I know some of you do not know how to round properly, okay? Because as I've graded quizzes, I've seen countless rounding mistakes. I'm usually a little bit more forgiving on those, but it could get you in trouble. It could get you in trouble later on. Okay, so that's this. Again, some of you worked through it just fine, no problem, and many of you got full credit on this problem, but I know many of you did not. And I don't know what to tell you guys. Okay, you have to work with me. You have to work with me. That's all I need. All right, so let's go into chapter 7. Okay, so we have sampling surveys and the sampling distribution. All right. So let me just talk to you, okay? So this can enter your brain, and then we'll write things up on the board. Okay. So in the beginning, at the very first week of class, we said, does anyone remember why we even bother studying statistics? That's one of the things. Okay. We said it helps us to draw conclusions or make conclusions from limited data, right? And we said when we look at data, we aren't looking at everyone. What do we call everyone?
Population.
Everyone is called the population, but we can't study everyone. There's just too many people. So instead, we study a group. We study our data set, and we call that a sample, right? How do we select our sample? At random, okay? We select our sample randomly. So that means if I take 2 different samples, are those 2 samples going to be exactly the same? Okay? Highly, highly, highly unlikely. It's possible, but it's highly unlikely. Okay? So when I pick different samples, they're unlikely to be the same. And let's say we want to know what percentage of the population has blonde hair. Okay? Has blonde hair. So we randomly pick some people. Okay? And so let's say I pick 100 people and randomly pick 100 people from the United States. Approximately how much do you think have blonde hair? Yeah, I don't know. I have no idea. Right? I have no idea. Okay? And it depends, right? Like, what color is blonde? Is this blonde? Is this brown? It's whatever. But let's just say we ask 100 people, and 18 of them says they have blonde hair. Okay, so in our sample, the proportion that have blonde hair is 18%. Okay. Does that mean the population has 18% blonde hair?
No.
No. Okay.
Or we don't know.
We don't know, right? We're hoping that our sample is representative of the population, but it may or may not be, okay? And we know that, so that was one sample. One sample I selected 100 people, and 18% were blonde. Let's say I pick another random sample of 100 people, and we count how many people have blonde hair, and let's say in that sample, 16% have blonde hair. Okay, it's very likely possible, right? We take another sample of 100 people, and maybe 21% have blonde hair. Okay, so we've taken 3 samples. They all have different proportions of people with blonde hair. But what does this tell us about the population proportion? So one sample had 16%, another sample had 18%, another sample had 21%. What do we still understand anything about the population proportion?
Yeah, between 16 and 18.
Maybe. Could it be outside of 16 and 18?
A little bit.
It's possible, right? We would, so from this, we feel like, anything between 16 and 20% sounds reasonable. Maybe even things outside of that also sound reasonable. But if it's vastly different from 20%, let's say 40% or 50% blonde hair, that would be surprising, right? We would not expect the population to be 50% blonde hair. Okay, so that intuition that we have, okay, will play a part in our sampling distributions. There's going to be math to support this idea. Okay? The idea is we want to understand what different random samples, what the proportion of different random samples might look like. Okay? So if I took a random sample of 100 people, what are likely or unlikely proportions of blonde-haired people? Okay. Are we following this? Shake your head if no. No? Okay. We have okay. Can I call on you to ask a question regarding this? Yes.
Can you write like a version of everything you just said in like one sentence?
Yeah. I'm gonna write everything up on the board, okay? But I just wanted to tell you about this to see if you understand the concept, and then that way, because when I write things up on the board, sometimes people get caught up in just copying things down and miss what I'm saying. So.
So Cass, what you're saying is, until now we've done like one group.
Yes.
And now we're gonna do groups of groups.
Right. So until now, we've just said like, hey, if I pick a random person, what's the probability that this person's over 5 feet tall? Or if I pick a random gorilla, what's the probability that it's between these weights or something? Okay. Now we're saying if I take a random sample, so a random group, what's the probability that this group has some property? This sample has 20% blonde hair or something like that.
Compared to the rest of the population.
Compared to, or just
Or other samples.
compared to other samples, yeah. Okay. So, we have a population. And from that population, we select a sample, okay? And in our sample, when we observe a sample, we get a p-hat. What is p-hat? P-hat is the observed proportion. So maybe the first time I draw p-hat, maybe I get 18% blonde. Let's say I draw another sample. Okay. P-hat could be 16% blonde. Yes?
Is observed proportion the same as estimate probability? Didn't you say it was like estimated something?
I guess we're estimating the proportion in the
Right.
population. Kinda. Yeah, I guess. I wouldn't say probability, though. It could be okay, though. Alright, and if I take another sample, that p-hat could also be 0.21, okay? And let's say we continue to just draw random samples, okay? Many random samples of 100 people. Alright. Is this okay? Okay. What kind of distribution of p-hat will we see? This is what we want to know. Let me look something up online. See if we have Okay, we'll frame this problem in another way. Okay, so this concept. All right, stay with me, guys. We can apply this. This was for figuring out the proportion of people with blonde hair. We could do this for anything else with a categorical variable, really. Okay, so for any other categorical variable also. say I have a giant tub of candy. Okay. And this is Reese's Pieces candy, alright? The like the ones that look like M&Ms, but they're peanut butter. Do you know what I'm talking about? Okay. I'm not a huge peanut butter fan, so I don't really care for this, but this is what our app does, okay? And let me just see what happens here. Okay. So let's say there's 3 colors of candy. All right. There's orange, yellow, and brown. These are the 3 colors that show up in Reese's Pieces. And let's say in the bucket, okay? Let's say we knew exactly what proportion is orange. What would you say the exact proportion of orange would be? Okay, so let's say the exact proportion is 0.3. So 30% in this bucket are orange. Okay. Let's say I take 35 pieces of candy. Okay, so I take a random sample. Of 35 pieces of candy. So what is my, and let's say 10 are orange. Okay, what is my p hat? 10 divided by 35, and I get 0.2857. I could take another random sample. $35 pieces of candy. All right. How many do you think are orange this time? Let's say 12 are orange. Okay, so I do 12 divided by 35, and I have my p hat here is 0.3429. Okay. If I do this over and over and over again, every time I draw a sample, I might get a different p hat, right? I might get 12 orange pieces again, and so I would get this p hat again. But every time I take a sample, I would get a different p hat, okay? Do this many, many times, okay? Record p hat each time. Alright, and we want to know what are likely or unlikely values of p hat. Does that make sense?
Yes.
Okay. All right, I'm gonna. Do we have a question?
It would take faster to do this now.
Huh?
Than do it over and over and over again.
Yeah, it's gonna take a while. most common value of p hat will be that we observe? Yeah, with this information, what do you think the most common p hat will be?
0.29.
Yeah, 0.3, okay, but not exactly 0.3 because there's no value. You can't get 0.3 exactly. All right, but let's. Is that thing turned on? Yeah, there we go. Okay, so here we've got. This is our machine.
0.333.
No. So we
Just
said
3/4?
in the giant bucket. In the giant bucket, there's 30% orange. That's what we're saying here. Okay. We picked the candies. Okay. We counted. I don't know. 3,000 orange candies and 7,000 yellow and brown candies. So there's a total of 10,000 pieces, and exactly 30% are orange. Okay. So we know this. We've set the population. We know what the population looks like. Okay. But we're gonna mix it up, and we're gonna pull out 35 pieces of candy each time. Alright, are you guys ready to see this? Alright, so I do this, okay, and it's picking 35 pieces of candy, and here we go. We're setting the orange ones over here, the yellow and brown ones over there. In this case, 11 of them happen to be orange, okay? 11 divided by 35 gives us, this just gives us, no, we want the proportion. Okay, 11 by 30 divided by 35 is like 30-something%, okay? So we put a little peg right here to indicate, we're making a dot plot, is what we're doing, okay? All right, we're gonna do this again. Da, 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 da. Okay, so in this one, again, this time, how many pieces are orange? 1, 2, 3, 4, 5, 6, 13 pieces are orange, okay? So our proportion there is 0.371, and we put a little peg right there, a dot plot. Okay, and we're going to do this again. So 4 orange, 5 orange, 6, 7. 7 orange pieces, okay? So only 20% orange. So a dot shows up here. Is this too small? Can you guys see that okay? Maybe I can blow this up. Alright, and then, okay, I'll do this one more time before we get sick of it, okay? So we have 6, 7, 8 orange pieces. 8 orange pieces is 23, like 0.229. So we put a dot right there. Alright, let's just, I'm going to turn off the animation so we can do this quicker, okay? And then, so in this case, there's 6, another 8, I don't know how many pieces that is. So every time I'm drawing it, it spits out a different proportion, and we're plotting, doing the dot plot, okay? It's not updating the picture, but it's calculating a different proportion, okay? And it's making the dot plot right here. So I can do this over and over and over again. Alright, is this okay?
Yeah.
So you can see how certain numbers are more common than others. Okay, and here I'm doing, so this is after I've done this 100 times. After I've done this 100 times, it seems like the numbers right here are more common. We get proportions of about 27, 29, 31, 34%-ish, okay, are more frequent than getting 11% or 50%. Okay, now I can speed this up, and I'm going to do 10 samples at a time. Okay? Okay, so after 10 more samples, you can't really tell, but the number of dots are increasing, and this is what it looks like. So this is after after 1,000 samples. This is kind of what it looks like. All right. What does it kind of look like if you had to describe the shape? Yeah, unimodal and almost symmetric. It's not quite symmetric yet, okay? But overall, it looks like it's unimodal and symmetric. It looks kind of like the normal model. All right, and then let's just do a whole bunch of samples. It's gonna take a little while. Okay, and this is where it starts to really look unimodal and symmetric. Okay, so it's looking more and more unimodal and symmetric, and we really see that these proportions are a lot more common than the ones in the extreme. Yeah, sure, it's possible to get 51% orange. When we take out 35 pieces of candy, it's possible for, 13 or 14 of them to be orange. Or no, like 17 of them to be orange. Okay? But it's unlikely. It doesn't happen very often. But for there to be like 10 or 11 orange pieces, that happens quite a bit. Okay, so that's what we see going on here. All right, and we could change what the bucket looks like. Okay, so here I said 30%. We've counted them out. But what if I change the bucket so that 50% of them are orange? Okay. What's this going to look like? Okay. Let me clear this. So if 50% are orange, I can keep drawing 35 pieces of candy out, and I might see something like 60% are orange, or something like that. Okay. And again, I can build up to 100 at a time. Okay. What do you think this thing is going to look like if I do if 50% are orange? I'm still drawing samples of 35 pieces of candy, but this time 50% of the candies are orange. Huh? Yeah, we're going to have a unimodal and symmetric distribution, but this time the center of the distribution is going to be around 0.5. Okay, and it's still unimodal and symmetric, but the center is around 0.5. 50%. Okay. So that is called the sampling distribution. The sampling distribution is the distribution of all those different p-hats. What we saw was that the sampling distribution is unimodal and symmetric. Okay, so I'm going to just write under certain conditions, and we will get to it. and that means, well, actually, the sampling distribution can be approximated very well by the normal distribution. Okay. So let's try an example. I'll work through it. Alright, so let's say I got a bucket of Reese's Pieces candies, and let's say we know that the proportion of orange pieces is 30%, okay? So we know the population proportion. We understand this sentence? Okay. And I want to know, if I take a random sample, 50 pieces of candy. So here's the problem. So I take a random sample of 50 pieces of candy. When I look at my sample of 50 pieces, let me finish this and then I'll answer your question. When I look at the sample of 50 pieces of candy, what's the probability that my sample only has 25% orange or less? Okay? And I look at the sample. What is the probability that only 25% of the candies are orange? Or less. 25% or less. Candies are. And I want to make sure we understand what this question is asking. Yes, question.
Does it matter, when you say a random sample of 50 pieces, does it matter if it's out of the total number of candies you have in that bucket?
It matters that it's 50 pieces, but it doesn't matter how big the bucket is.
So the overall number of the people in the population doesn't matter at all?
As long as it's at least 10 times bigger than my sample. But we'll talk about that. Okay. So if my population is not that big, 50 might be too many pieces. But if it's a very big population, 50 pieces, fine. All right. Do we understand what this question's asking? Okay. So how are we going to solve this? Okay, we're going to use properties of the normal model. Okay. So I just told you that the sampling distribution can be approximated very well by the normal distribution. We have a question.
Why is there no p-hat? In your p
So this has no hat because it's the proportion in the
Oh.
population.
Oh, okay.
Okay. But the p hat is what? It's the proportion of the sample.
Oh, okay.
So I'm just asking, so one thing is I could say, what's the probability that p hat is 0.25 or lower? That's another way of asking this question.
Okay.
Alright, the sampling distribution of p hat though. Sampling distribution of p hat, we will say is normal. And the mean is equal to p, and the standard deviation is equal to the square root of p 1 minus times 1 minus p divided by n. P multiplied by 1 minus p divided by n. So these are all the different values that p hat can take.
So the mean is always going to be, for this case, 0.3?
Yeah, the mean is the same proportion as the population proportion. So if, and that makes sense, right?
Yeah.
If in the bucket I've got 30% orange candies, whenever I draw a sample, I'm expecting around 30% orange candies. Sure, because it's a random sample, I might have more orange pieces, I might have fewer orange pieces. But overall, if I had to guess what the average proportion of orange pieces I get, I would guess around 30%. Yes?
Is that a 1 minus p?
Yeah, it's a 1 minus p.
Okay.
Yeah, I know
Over n.
in America we write ones like this, and in Europe they write ones like this. So this is
Is it over n?
huh? Yeah, 1 minus p divided by n.
N is the sample size.
That is the sample size.
So that would
Yes.
be 50.
That would be 50. Yes, exactly. Okay. All right. So let's talk about what our mean is. Our mean is equal to what? 0.3, and my standard deviation is equal to the square root of 0.3 times, what's 1 minus 0.3? 0.7 divided by n, which is my sample size 50. So I have to do this in my calculator. And I get 0.0648. Is that okay? And now I want to know what's the probability that only 25% of the candies are orange, or I should say 25% or less are orange. Okay? Do we know how to answer this? We do, okay? This is just a normal model problem. The mean is 0.3, the standard deviation is 0.0648, and you want to know what's the probability of getting 0.25 or less. So I could change this to say the weight of paper clips has a mean of 0.3, I don't know, 0.3 ounces, and has a standard deviation of 0.0648. What's the probability that a paper clip weighs 0.25 or less? Okay, it's the same type of question, except now we're not talking about weights of paper clips and weights of cows and tigers or whatever and bears. We're talking about the proportion in a sample.
So
Yes.
basically you would look through the area to the left.
Exactly, exactly. So what's our next step? I heard someone say it.
Find the z-score.
Find the z-score, okay? So my z-score I would get my z-score by doing what? 0.25 minus 0.3 divided by 0.0648. And I get negative 0.772. So I get negative 0.772. I look this up in my table, so I round to negative 0.77. And I look it up in the table, and what do I get? The area is 0.2206. So it's like I go here and say 0.3 is right here, and I'm looking for 0.25 or less. And when I look it up in the table, the area is 0.2206. Yes, Daniel.
I didn't get how you got 0.0648.
Do you have a calculator?
Yeah, I did it, but I'm getting different.
What are you getting?
I got like 0.00042.
Okay, did you take the square root of that?
How do you take the square root of an answer?
So if you have my type of calculator, you hit the square root button, and then you hit the answer button.
Oh, okay.
Okay?
And that will give you the last answer.
It should. Okay. Everybody try this out on your calculator. See if you can get 0.0648 on your calculator. 0.3 times 0.7 divided by 50. Take the square root of that number.
Thank you.
Okay?
So in the table you look for minus 0.77.
Yes.
And
And the area, wait, did I do this wrong? 0.77? I get 0.2206 as the area.
yeah. Okay, thank you.
Uh-huh. Yes, Danielle.
So is now 0.206. P-hat is basically 22%.
That's not p-hat. This is the probability. The answer to this question is 22%, but that's not p-hat.
Oh.
Okay? P-hat is our sample proportion. This is not a sample proportion. This is the probability that our sample is 25% or less. We have a 22% probability that our random sample has 25% or fewer orange candies. I'm gonna write that down. So my answer is 0.2206. Just want to make sure everyone's following me so far.
No.
No.
So what would you use hat?
Okay, so the p-hat comes in at, what is 25, but that doesn't matter. This is, don't worry about the letters, the p-hat just yet, okay? This is a normal model problem, and you get this, and you get this, and you get this. And so our answer to this normal model problem is 0.2206. If we're okay there, we're okay.
What it is again, it's the probability that...
This is my answer to this question, and I'm gonna write it out. But I just want to make sure that we're okay that we got 0.2206. Okay. All right, listen up, because the understanding is the important part. Because you can get numbers. Some of you can do calculations just fine, but your understanding is shaky. And then some of you, well, I don't know. Okay. The probability that only 25% of the candies are orange or less, that answer is 0.2206 or 22. We can just round off to 22%. Okay. This says when we take a random sample, a random sample of 50 pieces. You know, from this bucket. Okay, there is a 22% probability that the proportion of orange candies is 25% or less. Move up, sure. Okay, this is the meaning of 22%. It's not a p-hat, it's a probability. Question?
So then if you were to ask 25% or more, you would find the area to the right?
Yeah, so what would that answer be?
1
minus.
I mean
Yeah, so 78%, right? So what's the probability that 25% or more of the candies are orange? The answer would be 78%. Do we understand this?
Yeah.
Okay.
Yeah, I don't understand the wording on it.
You don't understand the wording?
No.
Okay. So the idea is we've got this bucket. Okay? In the bucket, I know, because I'm obsessive and I went to the factory and I got orange pieces and yellow pieces and brown pieces. And I counted them out and I know exactly 30% of the candies in this bucket are orange. Okay? That's what this says right here. Okay? It's in real life it rarely goes that way, okay? But in this situation we're pretending I know exactly 30% of the candies in my bucket are orange. Okay? I stir them up, I mix them all up, and I randomly select 50 pieces. When I randomly take a random sample of 50 pieces, and I count how many of these are orange. Okay? It's possible that 30% of my candies are orange. It's possible that 40% are orange. It's possible that 20% are orange. What this is saying is that I've got a 22% probability that only 25% of them are orange. Okay, I know it feels weird because we've got percent and percent. Okay? But this is the probability that my sample has this proportion. Okay? And that's why it's a sampling distribution of p-hat. Okay? It's a sampling distribution of your sample proportion. Okay, it's a tough concept, but you gotta learn this. Okay, you're gonna see a problem just like this on next week's quiz, star. Okay, and I'll give you another example that you can try out. All right.
So 22% of this sample, right?
No, it's a 22% probability.
Probably, yeah.
Right?
Of this
'Cause
specific sample that we chose.
that this sample
Yeah.
has only 25% orange.
Right.
Okay. It's
Not saying that all samples are going to be like.
Yeah,
So we say
right.
that this sample that we just took.
Yeah, this sample that I just took, maybe it has a bunch of orange pieces, maybe it doesn't have that many orange pieces. Okay? What's the probability? For some reason I asked, what's the probability that only 25% of my sample is orange? And that probability is 22%. Okay?
Standard deviation, where then you put up there,
Yeah.
find the standard deviation of
The sampling distribution.
sample distribution.
All right. Do we feel comfortable with this?
Yes.
Kind of. All right. I'm going to do another example. I'll write a problem up on the board, and you can see if you can do this. All right. And if you can do it, you should be fairly well prepared for next week's quiz. If you can't do it, you have an example that you can study. for next week's quiz.
Is this quiz like one question?
No, there's 3 questions. I got a lot of stuff to cover, all right? This is one of the concepts. I've got a few more to cover. It would be nice if it was just one question, right? Be easier for you, easier for me. Huh? It's bad if you. It's a high stakes game. Okay. Okay, so let's all right, let's say there is a school. Okay. And let's say at this school we know that exactly 53% of the students are female. Of the students at this school. We're going to take a random sample. We randomly select let's say 25 students. Right. What is the probability that less than 50% of our sample is female? Okay. So everything you need to solve this is written on the board. You do need your normal table. It should be okay.